When a light is pointed through two different substances, the light will bend because of a concept called refraction. This can easily be seen when a laser pointer is shown through jello. To demonstrate that the speed of light will change in different substances, I turned on the laser pointer and directed the laser through the jello, which is the new medium. I was curious to see if or how the speed of light through jello would change if the jello had changed colors. Through 3 trial runs with different colored jello, clear, orange, and blue, I can conclude that the color of jello does not affect the speed of light through the jello. To further my investigation, I decided to test the speed of light through other mediums, such as glass and plastic. For the demonstration, I decided to use a plastic cube rather than jello because it was easier to show what was actually going on. When using jello, the process is exactly the same. To repeat the lab, first outline the shape of the jello onto a piece of paper. It must have 2 parallel sides. To measure the correct angles, first place 4 points on the paper. One where the laser leaves the laser pointer, one where the laser enters the jello, one where the laser leaves the jello, and one where the laser has continued on through the air. The first and fourth point should be done so that it measures where the light is shining in air, and the second and third measure the light in gelatin. Next, connect the first and second points, the second and third, and the third and fourth. Draw a line perpendicular to the jello at the point where the laser has entered the jello, otherwise known as point 2. This line will be called the normal. Now measure the angle between the normal and the line between points 1 and 2. This is called theta 1. Measure the angle between the normal and the line between points 2 and 3. This is called theta 2. If the line between points 1 and 2 and the line between points 3 and 4 are not parallel, make another normal at point 3 and take 2 more measurements on the other side. Then take the average for more accuracy. This is what your measurements and lines should look like. With the measurements, we can use Snell's law to find the speed of light in gelatin. It is known that the speed of light in air is 3.00 times 10 to the 8th, and through the calculations we found that the speed of light in gelatin/jello is significantly lower than the speed of light in air. Snell's law is sine theta 1 over sine theta 2 equals V1 over V2. This lab was successful because through different mediums with different densities, the light changes velocity, which creates the bend in light that we can see. The bend in light is called refraction. Depending on the density of the medium, the light will be able to travel faster or slower. For example, air is less dense than jello, so when the laser travels from air to jello, the speed of light will decrease. Through our favorite equation, velocity equals frequency times wavelength, we know that if velocity decreases when the light enters the jello from the air, something on the other side of the equation must change to accommodate this. The frequency cannot change because this is what defines the color of the laser. In other words, the red laser remains red no matter what substance it is in. This means that as velocity decreases, the wavelength must also decrease.